All right. Good morning. It looks like we are live, and I'm just saying hi to the three people that have checked in so far. So I'm going to give it a moment to, for everyone to get caught up and check in. If you're here watching, wow, we're up to 5 already. So if you're here watching, just say hi so I can see who's actually attending. And we are going to start in a few moments with the worksheet that I gave you on Google Classroom yesterday. So we're going to start by looking at this, and all you had to do with this worksheet was to come up with the molar mass. Okay, a couple people checking in. Very good. So this unit, as I was saying yesterday, can feel fairly complicated. Okay, but it's not all that bad. To be honest with you, you're only learning a few new conversion factors that you're going to apply to the same problem-solving skill set that you developed when we learned dimensional analysis back in Unit 3. So, what's up, guys? So we're going to be just extending that. Now, before we actually get to solving some problems, we need to learn about those conversion factors in the first place. Yesterday, we learned about the molar mass, where every mole, depending on the element or the compound, has a certain mass. So one mole will equal a certain amount of mass, and you go to the periodic table to figure that out. All right, so let's go to the worksheet that we were talking about, and let's put up the periodic table as well. So you're going to be using the periodic table to determine the masses of these things. So lithium has a certain mass for number 1, and iodine has a certain mass. When you add them up together, you should get around 133.8 or so. All right, now I know we said that you're going to give me 3 decimal places, so we're missing those 2. But for the answer key that I have, that's what I got. So without actually doing the math myself, this is what you should have got. You should have gotten close to that. The next one, you have 1 lead, 1 carbon, and 4 oxygens. That should add up to be about 283.2. Okay? If you guys are getting close to this, you're on the right track. And again, you should have 3 places after the decimal. Now, the next one might be a little tricky. We have to really focus on this one. You have 1 magnesium, but you have 2 oxygens and 2 hydrogens. And when you add them up, you should get, that doesn't make much sense. Let's see here. Magnesium, 24, 32. Yeah, okay. So you should get around 58.32 something. Okay. You guys should be checking your work, and hopefully you tried this yesterday. The fourth one, 3 potassiums, 1 phosphorus, 4 oxides. That should be a mass of about 212.3. Okay. Now, the units, we haven't really specified what they are. This is grams per mole. Grams per mole. So that's another way of saying, let's take this first one here. It's the same thing as saying 133.8 grams for every 1 mole. And there's your conversion factor. You can flip this around, write the mole up top, write the grams on the bottom, whatever you got to do. So those are the answers to the first 4. I'm going to go through and list the rest of them. There's only 10 of them altogether. So check your work here. Number 5 should be 149.1 grams per mole. Number 6 should be 180.2 grams per mole. Number 7, 399.9 something something grams per mole. Number 8, 99.94. Sorry, I lost my train of thought there. Number 9 is 126.9. And number 10 is 77.08. So if you got something about that, it should be good. You're not going to be rounding, okay, especially on the quiz and the test. I might round during the instruction to kind of speed things up, but all you're doing is you're getting the information from the periodic table and you're adding them up. You have to account for every atom. Okay, so I hope that makes sense. Now, having said that, you could always pause the video, rewind it, whatever, go back and take a look. I'm going to keep that paper for now just so we can review it. Let's see. I do have some blank paper here. Throwing things around the room. So, where's my pen? There's my pen. Okay. Now, let's go back to this camera here. And let's talk about the next bit. We are going to be talking about a thing called, where is it? Where did I put? Oh, man, did I lose it already? Man, I am a terrible teacher. Remember that mole roadmap? I guess I'll just make another one. Not a big deal. So we made a thing called a mole roadmap, all right, where we had moles in the middle, and then that's related to mass. We've already covered that, okay? On this direction, we're going to talk about a thing called representative particles today. Representative. I usually just call it rep particles. This is what we're covering today, all right? And in early next week, we're going to get into volume of a gas. Okay, so this is the mole roadmap. The mole, again, is very powerful because it can connect these three ideas. By the end of class today, it's really weird to say, by the end of today's lesson, you'll be able to connect mass to number of particles and vice versa. So you'll be able to go from mass to moles to rep particles. There's no direct link here between these two. You have to go through moles first, okay? So if you're ever in doubt, you're not quite sure what to do in this unit, just convert it to moles. It might be, getting you to the right answer anyway. So that might be the best thing you can do. Just go to moles, all right? So far, we know how to go from mass to moles, all right? Let's go back to, Let's turn off the periodic table. All right, so you're going to have this thing handy, all right? I'll try and keep this one instead of losing it. So, excuse me. All right, so let's talk about representative particles. Now, representative particles is a very tricky subtopic to this unit, all right? It's not that bad. But what you have to do is be able to understand what these things are made of. So let's say I had iron, just regular old iron. No charge, right? No charge. So the representative particles, or the smallest unit of that thing, would be called an atom, okay? Let's say I had iron 2. The smallest unit, or the representative particle of that thing, would be called an ion, okay? The representative particle of something like this is a molecular compound, so I would call that a molecule. All right, let's say something real common, sodium chloride. That's an ionic compound. So you're going to have, this is tricky, okay? The formula, I just said it. The representative particle of an ionic compound is called a formula unit. I sometimes abbreviate that as an FU, okay? It just gets you through the question. So there are the four possibilities. You can have an atom, you can have an ion, you can have a molecule, you can have a formula unit. Don't worry about the names so much. Just know that sometimes you're going to need an extra step to go from something like a molecule to an atom. We'll do a couple examples, all right? So for instance, 1 mole, no matter what you're dealing with, it could be any of these things. 1 mole of anything, all right, is always equal to 6.022 times 10 to the 23rd things. Okay, now it's a goofy number. This number here was created by a guy named Avogadro. Avogadro. All right. Hang on a second, guys. Yes, dear? Sorry about that. Tina's downstairs. She's home from work today, and she just called, and she said, "Hey, hun," up the steps. And I think she forgot that I'm recording. So I hope everything's okay. I'm going to text her real quick just to figure out what's going on. And let's see. Let's text my beautiful wife while I'm teaching. Let's see. So when this goes off, I can at least see that she's okay. The joys of working from home. Anyway, so you have a guy named Avogadro, old guy. He's long gone, whatever. His contribution to science was that he determined how many things were in a mole. Okay? So if you have 1 mole of anything, I could have 1 mole of apples. Then I would have 6.022 times 10 to the 23rd apples. It's kind of like 12 things in a dozen. It's just another equivalent measurement that you're going to use to make a conversion factor. So 1 mole is equal to 6.022 times 10 to 23rd things. How you figure out what those things are? Representative particles. So if I have a mole of iron, I would have 6.022 times 10 to the 23rd atoms. If I had a mole of iron 2, I would have 6.022 times 10 to the 23rd ions. If I had a mole of carbon dioxide, I would have that many molecules. If I had 1 mole of sodium chloride, I would have that many formula units. Give me some sort of feedback here, guys, that this is making sense, okay? Everything here is the basis for what we're going to be doing today. So this is very, very critical. Now, one thing I did leave out is that Avogadro came up with that. So we're going to call that Avogadro's number as a shortcut, so you don't have to say that over and over. Again, I'm looking for feedback that this is making sense. And with the delay, I'm just trying to get that feedback. I got 8 people watching and only 4 likes. For some reason, 7 people are watching. I lost somebody as we were speaking. So 4 likes. Okay, so Matt says that this is making sense. And Tina says that she's sorry and she forgot that I was recording. Okay. I'm going to text her again during class. Just making sure you don't need me. Maybe the house is being broken into or something. I don't know. We'll see what she says. Okay, so we are now going to use this information to do more conversion factors in which we can. All right, Zach and AJ also say they got it. Cool. So we're moving along. We're going to use this information to make new conversion factors, and then we'll do a couple of made-up problems, and then I will try and get you another worksheet to practice these as well, just like what we did yesterday, okay? You ready? Here we go. So I'm going to keep this information. Hopefully I don't lose that page as well, and we're going to come over here to this blank page. All right, let's say how many... All right, Zach, thank you for the like. I appreciate that. How many atoms are in, let's say, 2.3 moles of iron? Very reasonable, very straightforward, short question. This is an easier question compared to some of the ones we're going to see soon. So here's what you got. Those conversion factors that we've been talking about, whether it be the molar mass or Avogadro's number, you just got to be able to figure them out. They're not going to be included in the question. So we're going to start here. 2.3 moles of iron. Try and get into the habit of labeling what we're dealing with, okay? I want to know how many atoms, all right? So here we go. I don't even need the question anymore. I want to convert this to atoms. So 1 mole, because I'm canceling out moles, right? You always start with what you know, cancel it out in the first step, and go to something useful. Well, I can use Avogadro's number, and I know that I can do this in one step because the representative particle of iron is atoms. Now, let's do another question where that's not going to be the case in one step. Anyway, what you do is you just multiply like we've been doing, and you get an answer. Make sure you give me 2 sig figs. And once you guys get the answer, if anyone's doing the math here on the screen, just put up your answer. It's going to be a big number, okay? It's probably going to be like, I'm going to guess around 13 times, wait, no, 2, no. It's going to be, doing math, it's been a while. Let's see. Yeah, around 13 point something times 10 to the 23rd. So it might round up to 14 times 10 to the 23rd. Or you might get 1.4 times 10 to the 24th? Something like that. Give me an answer if you guys get that. Now, let's do another question while I'm waiting for that answer where it's not going to be a one-step, okay? Let's see. How many atoms are in 1.9 moles of carbon dioxide? Another very short, easy to do question. I want atoms, okay? Okay, 13.85 times 10 to the 23rd. With sig figs, it would be 14 times 10 to the 23rd. So I was right. Okay, see, I still got it. I know it's been a while for me to prove that to you, but I still got it. All right, now back to this question. How many atoms are in 1.9 moles of carbon dioxide? So 1.9 moles of CO2. I don't even need the question anymore. I want atoms, right? So I'm going to multiply this with moles in the bottom. I want to cancel that out. And I'm going to use Avogadro's number, 6.022 times 10 to the 23rd. Now, this is where things get tricky, okay? CO2 is not made of atoms. It's made of molecules. So 1 mole of CO2, the representative particle is molecules. Okay? Now, there's going to be another step because I want atoms, not molecules, as my answer. How many atoms are in each molecule? And this is going to be different for each question. There is 1 carbon and 2 oxygens. So there's 3 atoms for every molecule of CO2. 1 molecule, 3 atoms. So that's the work you would do for this question, okay? There's the question, there's the work. So if you need to screen cap that or whatever you got to do, you would do the math, 1.9 times 6.022 times 10 to the 23rd times 3. Now, here's a tip. Here's crucial. You really, really need to worry about order of operations here. If for some reason, if you got to put this in a calculator, and most of the time you will be, all right, you need to put Avogadro's number in parentheses. So always put that in parentheses. Otherwise, you're going to get the wrong answer. It's just not going to work, especially if this is in the denominator, depending on what the question is. If Avogadro's number is in the bottom part of the conversion factor, you're going to be dividing by 6.022 and then multiplying by 10 to the 23rd if you don't put it in parentheses. So the order of operations is critical here. You have to be very, very careful. I hope this question makes sense, and if you guys got the answer, why don't you do it real quick, being careful with the parentheses, put it up in the chat so we can have some closure on this question, okay? In the meantime, I'm going to scroll up a little bit while you guys work on that. Scroll up like it's a computer screen. Oh, boy. All right, so just using these words I would use in class. So anyway, let's say I have a different way. How many moles do you have in, let's go nuts here, 2.02 times 10 to the 15th molecules of carbon monoxide? All right, so there's your new question. Okay, it looks like AJ and Matt both have an answer that is the same. I'm going to go with Matt's because of sig figs. All right, AJ, I hope that makes sense. We had 1.9 moles, so your answer must have 2 sig figs. Okay, very good. All right, now here's your new question, okay? Now we're going the opposite direction. We're going to have a starting number in molecules. So 2.02 times 10 to the 15th molecules. Okay. Multiply that. Let's get rid of molecules. 6.022 times 10 to the 23rd molecules. All right. Avogadro's number. The rep particle for CO. This is a molecular compound, so the smallest unit is a molecule. That'll get me to 1 mole. Now, this makes sense if you just have been following along with the conversion factors. Make sure you put this in parentheses for the same reason that you would put Avogadro's number in parentheses. You should get something less than 1 mole because this isn't quite as big as a mole, and you're dividing it by 1 whole Avogadro's number. So you're going to get a partial, okay? 3 sig figs in your final answer, and that should wrap that question up. So same thing. If you guys get an answer, put it in the chat so those following along could at least get some sort of closure, all right? Next, let's start including some sort of math or mass in our math, okay? Here we go. How many atoms are in, and I'm just making this question up, are in, let's say, 10.0 grams of sodium chloride. All right, trying to keep it simple but challenging. All right. Still waiting for some closure for that last question we did. And this is the new one we're working on now. Okay. So you're going to start with what you know. 10.0 grams. AJ says he's got 3.35 times 10 to the negative ninth. Is that negative 9? My old eyes. Anyway, 10.0 grams. Let's get rid of grams. Remember we said if you're ever confused, you're not sure what to do, just go to moles. So I'm going to go to moles. Okay. Now, how many grams are in 1 mole of sodium chloride? Well, with that, thank you, AJ, negative 9. With that, you have to go to your periodic table. Now, if I go to the periodic table, let's find a mass for sodium and a mass for chlorine. Now, I know what it is off the top of my head just because I've done so many. But again, this periodic table on the screen doesn't have that. So you need to check your own, and I need to get a better one for next time. So the periodic table I have here at my desk that I've been using, sodium should be 22.990, and chlorine should be 35.458. I'm going to round that to 58 just for ease of getting through this question. So you should have a molar mass of sodium of about 58. Now, we're not in atoms, okay? I want to cancel out moles. Now, how many things are in a mole? Well, Avogadro's number, 6.022 times 10 to the 23rd. Now, here's the problem. What is the representative particles for sodium chloride? If you think back, they would be called formula units. Not atoms, okay? The sodium chloride is not made up of atoms. It's made up of a thing called a formula unit. Now, that one formula unit is made up of 2 atoms. And there you go. That's all the work you need, okay? Put everything in parentheses that you need to, do the math, and, yeah, you get your answer. Should have 3 sig figs here for this particular question. Same deal. You guys get the answer. Put it in the chat so people following along can see it. Now, at this point, we've covered everything from the mole roadmap for those last 2 left and right sections, okay? So we've covered this stuff. We went from moles to mass. We went from moles to representative particles. And then just now we did a question where we went from mass to moles to rep particles. So we did it all together. You can now connect those 2 pieces together going through moles first, okay? It's not that bad. I'm going to try and find a worksheet that is appropriate based on what we just did. If you haven't finished the previous worksheet, then you're going to want to try that too. Again, even though you saw the answers, give it a shot, compare your work, okay? So I'm going to wrap it up here unless you guys have any specific questions. You've seen a variety of questions that I kind of made up, and they're not very different than what you would see on the quiz and the test, but we're baby stepping it, okay? So check Google Classroom for another worksheet. I'm going to spend the next couple of minutes trying to come up with one that works based on what we just did. And give that a shot over the weekend. On Monday morning, when we do our live stream then, we are going to start by going over some of the questions of this new worksheet. All right? Hope that makes sense, and thank you, everybody, for checking in and dealing with me as your teacher from afar. Appreciate it, and I'll talk to you guys again on Monday. Again, check that worksheet, give it a shot. We'll go over it on Monday. Thanks.